All right, class. So today we'll cover circular motion. So circular motion is related to your laws of motion, as well as this is related to your vector. So as well as this is related to your rotational motion. So we'll cover circular motion in one go. As in one class, we'll cover all the portions of circular motion that will be coming and that are included in rest of the lessons. Again, I'm telling you, wherever you have to study, just keep in mind that you have to have chapter vectors, circular motion itself from rotational motion, some portions from work, energy, and power, and maximum portions from laws of motion. These are included. All right. So these many parts you have to study, otherwise you'll be able to find it. Circular motion is usually excluded in that way, and we'll also do it separately. Yes, so kinematics of circular motion says what? You have to understand angular displacement. Angular displacement basically says that, see, whatever is the linear displacement, right? Whatever is the linear displacement. If angles are swept, right? If angles are swept, then we write it as angular displacement. So whatever is the angle that has been swept, like here, there is certain angle, this was initial, it is swept, so this is known as the angular displacement. So we represent it through theta. But when there is change of angular momentum, we call it as angular velocity. The way for linear displacement, we write we write linear velocity. Similarly, for angular displacement, we write angular velocity. This is rate of change of angular displacement. Omega is equal to theta by t. Angular displacement is theta by t. So radian is the SI unit for angular displacement. Radian we write it. So radian per second, right? This is getting divided by time. So radian per second is going to be the SI unit for angular velocity. So radian for angular displacement. Now it's an axial vector, so rotational effect it will be producing, and direction is along the axis of rotation. Axial vector means only when the axis is along the direction of rotation. Same way, angular velocity is represented through this omega. This is theta by dt. And angular displacement by angular time, it's an axial vector, and you write it as radian per second. Now it can be uniform, it can be non-uniform. When both magnitude and direction of velocity are remaining the same, magnitude is also the same and direction is also remaining the same, we say it's uniform. But if any of the quantities will change, either magnitude or direction, we say this is non-uniform. So uniform circular motion is more important to you. In non-uniform, you can directly write delta theta by delta t when you are calculating for a certain duration of time, and for any instant, you can take differentiation, d theta over dt. There's a relation between angular velocity and linear velocity. This is very important. V is equal to omega r. So any analogs are written like this only. The way we write, for torque also we write it as r cross f. Similarly here also. So this is linear velocity, angular velocity, and the radius vector. So V is equal to omega r, we write. Lastly, we have angular acceleration. This is angular acceleration alpha. So alpha is going to be d omega over dt. Or you can use, if duration is given, change in angular velocity by change in time. So the chain keeps on building up, right? You have theta as the basic quantity, which is displacement, right? That is the very basic quantity, displacement. Then once you are through with displacement, you find the rate of change of it. Once you are finding the rate of change of it, then what is happening? You are getting a new quantity, and that new quantity is termed as angular velocity. Now this new quantity is again independent of itself. So once you have angular velocity, it will also be changing with respect to time. It will also be changing with respect to position. But position, that will become a special case then. All right. So these much portions you have to remember in the basics of it. Rest of it, these are very basic portions of circular motion, basic parts. Under uniform circular motion, magnitude of linear velocity remains constant. Direction of linear velocity direction of linear velocity can change, magnitude of angular velocity remains constant, and angular velocity's direction changes. Now you have two types of accelerations. Due to change in the direction of velocity, that is coming a tangent, we have tangential acceleration. And the one that is acting along the center because of change in magnitude, that is centripetal acceleration. So we have these formula also. Acceleration is written as v square by r. And if you put v as omega, that becomes AC is equal to omega square r. That's what you have to remember. Now, under non-uniform circular motion, when velocity's magnitude changes, you write tangential acceleration. When direction changes, you write centripetal acceleration. Similarly, when omega changes, you write angular acceleration. When direction of omega changes, there isn't any acceleration. So tangential acceleration also you can differentiate. So this is the basic state. Radian for displacement, radian per second omega, and alpha, that becomes radian per second square. Yes, this part also. So you have tangential acceleration that is acting along the tangent. You have angular acceleration that is acting along the center. This is because of centripetal force. This is like centripetal acceleration, right? So tangential acceleration and radial acceleration. So centripetal acceleration and tangential acceleration, they can easily be used using your parallelogram law. So directly use this because this is going to be 90 degrees. So 90 is 0. So under root a square plus c square. And tan beta is equal to AC by 8. This is what you can use. Centripetal force also you should remember. mv square by r is the general formula, or mass into centripetal acceleration you can write, or m into omega square into r. This part you can write. Yes, these questions are also there. Safety limit. See, safe limit means when the vehicles are turning on the road, the vehicle shouldn't skid. So the derivation is not important to you. What you should remember is that velocity should be less than or equal to mu rg. And this is the safety limit. This value is usually written on roads for the general vehicles, like trucks for different cars differently, like this. So this is a minimum value because at a turn certain calculations are made for which if the velocity is crossed, centrifugal force will overcome centripetal force, and that can lead to skidding of the vehicles. So that's why mu rg, where mu is the coefficient of friction, r is the radius, and g is acceleration due to gravity. For bending of road, this much you should remember. Just in case your road is inclined, your vehicle is inclined on the road, slopes are there, no, on the road also, then what you can do, again, do not go through the definition. Just remember this formula: v is equal to under root rg mu cos theta plus sine theta divided by cos theta minus mu sine theta. That's it, what you have to remember. Now, if a cyclist is bending, same thing, but just remember formula is the way we write, no, mu as tan theta in friction. Yesterday only we did. So remember in that order. So safe limit for cycle is under root rg tan theta. These formulas are important, out of which this is the most important formula. Rg under root rg mu cos theta plus sine theta divided by cos theta minus mu sine theta. At least this much portion all of you should know. So any formula if you want, you can note it down right now also. Let me know if you want to write down any formula. Otherwise, I'll begin with the questions practice then. So any formula if you want, just let me know. I'll write down the question, same thing. And class, the formula which I've told you, right now, under root rg1 mu cos theta, bending of a cyclist on an inclination. That is the most important out of it. Questions have come.
Ma'am, can you show that formula?
Yes. That's why I want you all, at least you should have an idea for the formulas. From the circular motion, see, these are the basic formula everybody knows. Out of which, no, these formulas we are not in a habit of writing because obviously these aren't used in our 12th classes. So these formulas that are present at the end, these you should write. Bending of road, at least write it right now. Bending of road, make an arrow, just write it so that you will be having it with you. Then this is bending of road on an inclined plane where inclination angle is theta. Note down this one. Then bending of cyclist, safe limit. All right, let's practice the questions now. So only Saifullah has answered. Others, Saifullah, your answer is correct. Hanifa, good. Answer is right. Okay, last 2 minutes and I'll discuss it. Yes, good. So 3 students have answered it correctly. It's good. Saifullah, Hanifa, and Ellen. See, class, in this question, alpha is given to you. Angular acceleration, this is given to you 2 radian per second square. Omega is alpha t, right? Omega is alpha t. So if you will multiply it 2 seconds with this 2, so that will be 4. 2 into 2, this is going to be 4 radian per second. Centripetal acceleration will be omega square r. Omega square will be 4 square. Radius is 0.5. So half into 4 into 4, 8, right? So centripetal acceleration would be 8 meter per second square. Now for linear acceleration, if you find out, or the tangential acceleration, that is alpha r. Now alpha, it was 2 and this radius was 0.5. Cancel 1 meter per second square. So net acceleration, this is not the net acceleration, we have 2 accelerations. Net acceleration will be under root 8 square plus 1 square. So this will be under root 65. But see, this would be something 8 point something. And exact answer option is not given. So let's write it as, we can almost write it as root 64 only. That will be 8 meter per second square. This
Ma'am,
depends.
you can use omega square r, right?
Yes. Omega square
Sorry,
r.
ma'am.
Yes, yes. Omega square r. Here. This you were saying?
Yes, ma'am.
Okay. So option D is correct, right? So just quickly note it down. Yes, so most of you have given the correct answer. Alan, Aksa, Seth. Here you will use the same formula that I have told you. V is equal to under root RG tan theta. So V square will be RG tan theta. Isn't theta given to you? And what is tan 45? Tan 45 is 1. So speed you have to find out. Speed will be Farhat, no, I think some error is there in your answer. Under root RG, that is 90 into 10. Under root 900, or you write it as 30 meter per second. So B option, not D. Yes, so Farhat and Saif have answered correctly. Here you will use force. Which force will be used? See, it says a ball of mass, whatever mass is given, this is attached to a string. Yes, Aksa, correct answer. So length is also given. Length is 1.96 meters. The mass is also given as 1/4 of kg. And tension is given to you. Tension across the string is 25 Newton. So tension is actually providing this necessary centripetal force. So tension will be mv square by r. Use this relation. Now what will be velocity from here? RT by m under root. Just use this formula, you will get your answer. 25 into 1.96 by mass is 0.25. When you will solve this, this will come out to be 196. So root 196 will be 14 meter per second. And tension at highest point is 0, lowest point is maximum. Note it down, those who have it. So only Alan answer is right. Seth, it's not D option. See, if it's a cylinder, this is not given in your question. Let's talk about here, right? When it's rotating about its vertical axis, means this is omega, this is rotating like this. So what all forces will be acting? Here, normal reaction will be made, right? Outwards, you will be, it will be experiencing centripetal force, mv square r you can write, or mr omega square you can write, centripetal force. This is normal reaction. Downwards, always gravitational force acts. Now it has a tendency to fall downwards. So frictional force will act upwards. This is what was the FBD, which you have to remember. It can be concluded that the block will be stationary when limiting friction. I'll write it down. Limiting friction is greater than or equal to mg. Otherwise, when mg is greater, this will fall down. Because of gravity, it will fall downwards due to the weight. Now, magnitude of limiting friction between two bodies is directly proportional to normal reaction. Yesterday only we had seen. So this is equal to mu n. Now, yes, class, look here. Is n equal to mg? No. So you cannot remember f is equal to mu mg. Mu n only. But n is equal to what you can write. See, mu n, we can write now mu n is greater than or equal to mg. If you substitute the value of friction here, mu n is greater than or equal to mg. And what is normal reaction this time? Normal reaction is balancing this. Normal reaction is equal to mr omega square. So this will be mr omega square greater than or equal to mg. Right. Now from here, mass will get cancelled. We have to write omega, no? Omega will be greater than or equal to G divided by R mu and under root. So minimum, for the minimum value, it has to be equal and otherwise greater. So this is going to be 10 by 1 into coefficient is 0.1. That will be root 100, which is equal to 10 radian per second. Note it down. So yes, B option was right. Your chemistry class will start 15 minutes earlier today, class. So whatever is the usual time, I think from 5. So it's going to be 4:45.
But ma'am, we don't have chemistry class today.
You do not have chemistry class today.
No, after this we have biology.
Just a minute, let me confirm then. Class, you usually have your chemistry, you usually have your biology class, no, today. But sir is not available, so Salim sir will be taking your chemistry class only. And he'll be taking 15 minutes prior the given time. So you will all be having your chemistry class today instead of biology. And the class will be taken by Salim sir 15 minutes prior the original time. So from IST. one end of the string of length L is connected to a particle of mass M, and the other end is connected to a small peg on a smooth horizontal table. If the particle moves in a circle with speed v, net force on the particle directed towards the center will be. See, if we talk about circular motion, this is the string, this is the ball connected. So accordingly, what all forces are acting? This is tension. Here outwards, we'll have mv square by r. Similarly, when it will reach this part, tension will be acting here. Outwards, mv square by r will be acting and the particle will be residing here. So if force is asked for this part, what will happen? Tension is downwards. This is moving, no, here also, this is moving m square by r. Here you have mg. If tension is asked in this part, this is tension, this is mv square r by r. But is this the question? Do we have to find out the net force? We have to find out the force that is acting along the center. Net force acting towards the center, not the net force entirely. Otherwise, we would have written T plus mv square by r, right? T plus mv square by r. Net force, if we would have added it, or we would have subtracted it, mv square by r. But this is the net force all along. We are just finding net force along the center. Towards the center, which force is acting? Only tension is acting. So yeah, your answer, tension is equal to mv square by l. Otherwise, also, if you see, if it is just kept on a table, this is the particle, this is the length is L, this is moving with velocity V. Tension is actually equal directly also mv square by L. The net force is the centripetal force. So that's why answer will be only tension. So A part. Note it down quickly. All right, all those who have written, you can leave the meeting. After 15 minutes, your chemistry class will start. And the syllabus for Friday's test will be the entire laws of motion, including circular motion. Entire laws of motion will be included. All right, class. Thank you so much.
Thank you, ma'am.
Thank you, ma'am.